something like 40 or more marks on integration in your final exam. So integration is going to be one of the biggest topics. Some of the questions will be GR13 integration, but some of the questions will be, it could be GR12 integration, which is going to be polynomials, but then the difficulty is in finding the area, finding the tangent, or not the tangent. When you have the tangent, find the function. So it's going to be complicated in that sense, but it will be polynomials. Yeah. So I'm recording already, no? So let me show you the first question. Try to see if you remember how we are doing a question like this one, yeah? Hiya, hello, we are just starting. You haven't missed anything, yeah? This is the first question. I just was saying that these are all integration questions that you can do with the GR12 content, but they are all from GR13 papers, yeah? So it's important that you keep revising GR12 integration. Okay, so this one, you have the graph. It's a cubic. They even have represented for you, yeah? And we have to find the area. Remember, to find areas, we are going to integrate, and we are going to integrate between two limits. It's going to be definite integral. The danger that we have when we have curves under the x-axis is what? Can someone tell me? What is the problem that I have when I have part of the curve over and part of the curve under the x-axis? Bianca, tell me.
That if it's underneath, it'll be like negative area, so it actually gets you like, in a way, like the positive area minus the negative area, even though you just want the overall area. So we just take the negative area positive.
And then we add them together, exactly. When I integrate between two values, if my curve is above the x-axis, my answer is going to be positive. When I integrate and my graph is below, it's going to be negative, which means if I integrate between this point and this point straight away, my area could be 0 if they are equal to each other. And if they are not equal, maybe will be smaller than it should be. So every time you're integrating to find areas, if they don't give you a sketch, it's worth it to do a sketch to see if you have something under the x-axis. Yeah. If that's the case, we are going to integrate between this point and this point, between this point and this point, and then add them both but positive. So have you found the points of intersection with the axis? For that, remember, we are going to factorize the cubic. So we can write this. And x squared minus 4 is going to be difference of two squares. Yeah, so it's going to be x plus 2 and x minus 2. So exactly, those are the roots, 0, 2, and minus 2. Excellent. So this point is going to be minus 2, this point is going to be 0, and this point is going to be 2. So I'm going to integrate between minus 0 and 2, the minus 2 and 0, and then between 0 and 2. Or as this is symmetrical, we can integrate between 0 and 2 and multiply that by 2, yeah, or between minus 0 and minus 2 and 0. So let's go into integrate. To integrate, I need the function without factorizing. And if I integrate between minus 0 and 2, so I get it positive. Remember, to integrate, I just increase the exponent by 1, and I divide by the new exponent. So x to the power of 4 divided by 4 minus 4x squared divided by 2. I would write always the whole thing, and then if you can simplify, simplify. But if you try simplify straight away, sometimes we make mistakes, yeah? Between minus 2 and 0. We don't need to write the constant of integration when we have definite integral, yeah? So when I integrate between a and b, I substitute the b0, the top 0. So I have 0 minus, and then I substitute the minus 2. And I'm going to write a bracket just in case. Yeah, so minus, brackets, and I substitute the minus 2. So I have minus 2 to the power of 4 divided by 4, and then minus, I'm going to cancel these 2 and write 2. Yeah, so minus 2 times minus 2 squared. The more you're working out, the more chances you have to get all marks, just in case your final answer is wrong. Yeah, so that's why I wrote this 0 and the minus at the front. So if you have a value, this Tell me. I get 4. Did you get 4? Yeah, perfect. So the area is going to be 2 times 4, which is 16. Yeah, 16. Good. 8. 8. Yeah. So that's how we find the area, and that's why you have to be careful between. If you do the same integral, so if you do the same integral between 0 and 2, you will get a negative value. If all your area is under the x-axis, your value is going to be negative. Please remember to answer that the area is that value but positive. Yeah, don't give up an answer for the area negative. Even if the integral is one thing, the area is another. Yeah, so just be careful. Any question or is okay? Okay, more. Let me check that we get the 8. Okay, another one. So you have a function, in this case is a quadratic, upside down because the coefficient of x squared is negative, so it's going to be pointing down. They are going to ask us to find one area, but the first thing they ask is to write this one in this way, which is complete the square form. So these integration questions to find the area not always are isolated, just find the area. So usually it's a series of questions that find the tangent, find this way, factorize, simplify, use the factor theorem. So they are going to ask you a few things. Yeah. Do you all remember how to complete the square here? For people that I cannot see, do you show me thumbs up? Maybe you have thumbs in the so again, you remember, Zoe and Faria, maybe you can find the thumbs, or you just unmute and you tell me, or you, okay, you found it. Okay, so when we complete the square and you have a different number than 1 here, the first thing you're going to do is to factorize this -3 outside, yeah? If you remember how to do it, just carry on without, just ignoring me. Plus 12x plus 8, plus 12x plus 8. So first thing, I'm going to get the -3 outside for the first 2 terms. So the x squared and the other one, yeah? I don't need to do the 8. And then I'm going to complete the square for these 2. To complete the square, remember, I'm going to write in a bracket x. And if I have minus, minus. If I have plus, plus. Half of this number, yeah, which is 2. Squared, and then minus this number squared, which is 4. Which means if I go back to my expression, I have -3 multiplying x minus 2 squared minus 4, and then plus 8. Yeah, I'm just substituting the blue one by the expression that I found. And now what I'm going to do is to expand these 3 and put together the numbers. Just simplifying, yeah? So if I expand that 3, I have -3 multiplying x minus 2 squared. -3 times -4 is positive 12, so plus 12 and plus 8. So the final thing I have is -3 x minus 2 squared plus 20. Yeah? Faria, do you remember now? And again, Zoe and Priyanka, do you get the same thing? Yeah. Okay. So that's what they're asking me. They're asking me write f(x) in this form where a, b, and c are constant to be found. Whenever they ask you to find the constant, it's worth to write the constant. So not just the expression. So a is the coefficient at the front that was -3. B was -2. And C was 20. Yeah, just in case. Then the curve C has a maximum turning point and at M. So this is this function and it has a maximum here. Find the coordinates of M. How am I going to find the coordinates of M? If you have a quadratic, probably your first intention would be, I'm going to derivate and make that equal to 0. But if you have made the effort to write it completing the square, we have the maximum. Do you remember what the maximum is going to be when you complete the square? So we say this is -3 x minus 2 squared. Okay, what do you remember? What is the maximum?
Is it when you make x equals 2?
Yeah, And what is y when you make x equal to
20.
20? Yeah. So once you have completed the square, don't waste your time differentiating. You're going to get the same answer. But when you complete the square, the maximum or the minimum is what makes this bracket 0. And when the bracket is 0, this is y. So it's going to be 2, 20. Yeah. Well, this point is 2, 20. Yeah. Without doing anything else. If you differentiate, you're going to get the same answer. Then we have a sketch. The line L passed through M and is parallel to the x-axis, this line. What is the equation of this line, just in case we need it? Y equal 20, yeah? The region R shaded here. So this one is bounded by C, L, and the y-axis. Using algebraic integration, find the area of R. Remember, when I integrate one line, I'm going to have the area under. Yeah, so if I integrate this function here between this point and this point, what I'm going to get is the area under. So in these questions, in many occasions, I will have to do something else. So it's not going to be that straightforward. I will need to subtract from something else or subtract something from it. So it's not going to be just finding the integral. What can I do to find that gray area? Who can tell me? Okay, tell me.
Do you find the areas between 0 and 2, and then for the entire area, you just make a rectangle, and then you take away that area?
Exactly. So I'm going to find the area of the rectangle and then subtract the area that I get when I integrate. Yeah, so I'm going to have a rectangle and then subtract the pink area that is the one that I get when I integrate. So let's go into that. We're going to find the integral first, for example. Yeah. So the area under the curve is going to be the integral between 0 and 2 of my function. That was this one, minus 3, 12, 8. So minus 3, 12, 8. Yeah. So please integrate and see what you get. We increase by 1, divide by the new exponent. I'm going to simplify the coefficients before substituting, yeah? If you are careful and you don't make mistakes, you can simplify straight away. And I just think you got already one value, perfect. So we substitute the 2, and we have minus 2 cubed plus 6 times 2 squared plus 8 times 2 minus 0. It's worth to write the 0 so they see that you have substitute the 2 and then the 0, yeah? What about everyone else? Did you get 32? Yeah. So I get 32. Everyone gets 32, I think. So this is the area, the pink area that I draw here. Yeah, the area under the graph, because it's what I got when I integrate. The area of the rectangle, I know this is 20. So the area of the rectangle is going to be 20 times 2. Yeah. So the area of the rectangle, is going to be 20 times 2, which is 40. So R, the area I'm looking for, is the 40, the rectangle, minus the area under the curve, which is 8. Yeah. So most of the questions are going to be quite similar, I think. You are going to have bits that sometimes you have to think what I subtract, what I don't want, or and sometimes that is a bit of thinking, but then you're going to integrate. If you don't know where to start, I would recommend you just try to shade maybe the area that you get when you integrate, because that's going to help you, like I did here. I say, if I integrate this function, what area I'm getting? This one under, yeah? And with that, usually you get the idea, yeah? Is the question clear? More? Okay, let's do more. Let me check it. Yeah, okay. This one, This one looks a bit more complicated, but it's going to be quite similar. So we have the curve has this equation, is a cubic, so it's this one here. The point A minus 114, so this one, we know the coordinates of A, lies on the curve. The tangent A crosses the x-axis at B, and we have to find an equation of the tangent. So first thing, an equation of the tangent. Who can remind me what I'm doing to find the equation of the tangent here? What do I need? How do I find it? Etc. So it's 5 marks. How am I going to find the tangent? Can someone tell me the steps? Priyanka, what am I going to do? Maria, yes.
First, what you have to do is, since you have the coordinate and you have the equation, you differentiate it and substitute the coordinate of x, so -1, and then you'll get the gradient, and then you have the point, and then you can just find the equation.
Exactly. So we are going to differentiate the function. When we differentiate, we are going to substitute the x. That way we find the gradient in that particular point, and with the gradient and the point, we are going to write the line. Perfect. So let's go into differentiate. Yeah, it's quite simple. This year you're going to differentiate many more functions. You're going to differentiate product of functions, square root, trigonometric functions, exponential functions, logarithms. So it's going to be much more. But year 12 questions is always polynomials. So the 3 here in the exponent goes multiplying the 3 at the front. So I have 9x squared. The degree goes down by 1, and then -7. When I substitute my x by -1 to find the gradient exactly at A, I have m is 9 times 1 squared, which is 1, so 9 minus 7 is 2. So that's the gradient of the tangent, which means if you want to use this equation to find the line, I think is the best in this situation. So y minus the y of the point, so y minus the y of the point, that was 14, is going to be 2x minus the x of the point. So minus 1, I'm going to write +1 already, yeah? And then we can expand the brackets and organize a bit. So they say find an equation of the tangent. It doesn't say how, so you could leave it like this. But we are going to use it in the second part, and it's better if we have it probably organized, yeah? So 2x plus 2. If not, you can leave it like this, and it's completely fine. And so y is going to be 2x plus 16. So this is the equation of the line that they are asking me. Yeah? That's the tangent. Then find the coordinates of B. This point. I know the equation of this line. Zoe, would you tell me what I'm going to do to find the coordinates of B?
So x has 0.
X or Y? What is going to be 0 here?
Y.
Y. Exactly. So I'm going to make Y 0 in my line. So for the second part, to find the coordinates of B, I'm going to do Y 0. Y 0 means 0 is 2x plus 16, which means 2x is minus 16, which means x is minus 8. Yeah, they ask me the coordinates. So please don't just find the x, write the coordinates. So the coordinates are going to be -8, 0. Yeah, so write the answers properly just in case, because some questions they won't be picky on how you write the answer, some others will. Yeah, so those are the coordinates of B. So we know this point is -8. And now this question is super scaffolded. You see, they're asking us find the equation of the line, then find this point, then find the integral, and then find the area at the end. Some other questions will be straightforward, find the area, and that's the thought process that you should have. So if you need to find this area, you will need for sure to find this line, to find this point, to find the integral, and so on. Yeah, but you see how they are asking you step by step. So let's go into do this integral. A is the integral between -2 and -1 of this function here. Between -2 and -1, and I think I'm going to make space here. So -2 minus 1. Please do it. Don't wait for me to do it. And then we substitute the minus 1, and then we substitute the minus 2. Yeah. $37.4. That sounds like okay. Careful, we are substituting the minus 1, and then it's so helpful when 1 is 0 and everything goes. But if not, please be careful. It's just you don't want to make mistakes here. You could use the calculator. You know, your calculators have definite integral function. Yeah. So if you see your calculator, you have a function to integrate. So still you will, my recommendation is maybe you want to use that function and find the answer straight away, but still you want to write this and this to get the marks. Yeah, look, it's 5 marks. If you write your answer straight away, you're not going to get the marks. If you write only this, you get a couple of marks. So I would recommend you to write everything, even if you use the calculator and you know the answer in advance. Yeah. Do you all get the, okay, what did Faya say? 37/4? Did you get that too? Yeah, okay. 37/4. And then the curve crosses the x-axis at point -2, 0. So the curve is here. This is -2, -2, 0. So this is this point, -2, 0. Calculate the area, the shaded area, yeah, between the line, the curve, and the x-axis. How am I going to find that area? Who can tell me? What I'm going to do to find that area? Priyanka, what would you do?
So because if you draw a dotted line from -1 to 14, that's like a triangle. So then we would just do the area of the line from -2 to -1, and then do the triangle. So triangle minus, yeah, that thing.
Exactly. And that's why, look that they are asking you to integrate between -2 and -1. That should be already a clue. If we integrate our function, we are going to find this area, which is not what we want. So we are going to find the area of the triangle and then subtract the pink one. The pink one is the one that we just found here. So it's this one here. So the only thing that we need to do is to find the area of the triangle and subtract that one. Yeah. So this is 37/4. This one here, the pink one. Yeah. Area of the triangle, we know everything. So this length from -1 to -8 is 7. Yeah, this length is 7, and the height is 14. So the area of the triangle is 7 times 14 divided by 2. So the area of the triangle is going to be 7 times 14 divided by 2, which is 49. And then the area that we are looking for, the gray one, is going to be the triangle minus the pink one. Yep. I mean, whatever that is. I get 159/4. Yeah. Or if you want, 39.75. That's what you get. Is it clear how you can play with the area that you get when you integrate? Because these questions are all integration. So you are going to integrate your curve, and how you play with other areas to find what you need. Yeah. So these questions is just the same. Just sometimes it takes a tiny bit to see them. We get 159 divided by 4. Okay, perfect. More. Let's go into do more. So we have this one. So figure 3 shows a sketch of part of a curve with this equation. Yeah. The region R is bounded by the curve and the x-axis. Find the exact area of R, writing your answer in this particular form. This is one of the questions that are not scaffolded. They are not going to ask you, find the points of intersection and find the integral. No, you have to do it straight away. So what I'm going to do, what would be the steps that I'm going to follow? Okay, what would you do?
Would you do 4 root x to the power of -1?
To prepare this function to integrate, for sure. But before integrating, how I'm going to find the area? Integrating what and between what and what?
I don't know. We need to find the coordinates
Which coordinates?
when y equals 0.
Exactly. So first of all, I'm going to decide what are these points. And when I have these points, I'm going to integrate my function. Yeah. And be careful, because when I integrate this function, I'm going to get a negative value. Remember, I'm going to write it positive for the area. The integral is going to be negative. My area is going to be positive. What are those points? Can you type them in the chat? This point and this point. I hope all of you can see them very quickly. So what are these 2 points? Bianca says 2 and 4. What about everyone else? Do you agree with that? 2 and 4, exactly. So is this function here? Is going to be, the y is going to be 0 when this one is 0 or this one is 0. So 2 and 4. So I know what I am integrating between. Yeah. So I'm going to integrate my function between 2 and 4. This integral needs a bit of preparation. Yeah, we cannot integrate that straight away because we know how to integrate something that says a coefficient and x to the power of n. So what I can do is expand the brackets, because those brackets are not helping me in this situation. So I'm going to expand the brackets and then I'm going to divide each term by 4 root x. And remember, I can write root x as x to the power of a half. Yeah. So, and remember how I divide powers. So please try to rewrite that function in a way that I know how to integrate. Yeah. I'm going to do it in a minute, but I would like you to try to rewrite that function first. So I expand the bracket and I write x as x to the power of a half. And then I can divide each term. Yeah. So I have 1/4 for the first one. So I'm just dividing each of them. So this one by this, and then the next one, and then the next one. Yeah, each of them. I have x to the power of 2 divided by x to the power of a half. And just remember how we divide powers. So we subtract exponents. So we have x to the power of 2 minus a half, which is 3/2, no? 3/2. Then the next one, I divide -6 by 4. So I have -3/2. And x divided by x to the power of a half, which is x to the power of -1/2. And the last one, I divide 8 by 4, which is 2. And then I'm dividing nothing, so 1 by x to the power of a half. So it's just x to the power of -1/2 when it goes to the numerator. Do you get this expression, all of you? Yeah, so we are dividing each term, and just remember how we divide powers. Yeah, and now we can integrate easily. So we are going to integrate, we say, between 2 and 4, and we expect to get a negative answer. Yeah, because it's below the x-axis. So please integrate that. Just being careful, but it's not complicated. It's just a bit trickier when we have these exponents. I'm dividing by the new exponent, yeah? So I'm dividing by 5 halves. So I can write the 5 here and the 2 in the numerator if you want, yeah? Divide by 5 halves is the same as multiplying by 2/5. So sometimes it's better writing this way. Actually, we could put these two together, no? No, I'm doing something wrong. X minus a half, this is positive a half. This is positive a half, sorry. It's 1 minus a half, which is a half. It couldn't be the same. Before substituting, I'm going to arrange a bit the coefficients. Yeah? Did you get this? And now we substitute the 4 and then the 2 and subtract. This is just being super careful. It's so easy to make mistakes in this type of questions. Yeah, so if you get an answer, please type it in the chat so everyone can check. You are always faster than me doing these questions. We have to write in this way, so we cannot use the calculator. We cannot use the calculator because the calculator is going to give us, no, can we use the calculator? I think I'm going to do it slowly. You see why this is 6 marks, no? Here we have 2 to the power of 5 halves. If you write that in the calculator, it's going to give you the decimals. Yeah, so if you write 2 to the power of 5 halves, it's going to give you the decimals. So this is the same that the square root of 2 to the power of 5. So 2 2's can go outside, and then 1 2 can go inside. 2, no. So this is 2 to the power of 5. 2 to the power of 5. 2 can go outside. So this is 4 root 2. 4 root 2. This one is 2 root 2. And this one is root 2. Yeah, so is kind of long. So we have 4 root 2 divided by 10 minus 2 root 2 plus 4 root 2. Yeah, so plus 4 root 2. We have 16 over 5 for the first term. And then in the other side, we have 4 tenths minus 2 plus 4. Yeah, minus 2. I'm going to do this wrong, almost for sure. Minus, so this is going to be minus, and I have 12 over 5. Is that what you get? 4/5? It cannot be 4/5. Look at the and it must be even negative. So we're checking everything. 16. Ah, sorry, I forgot the root 2. I'm missing the root 2. Root 2. Is that? Yeah, is that. Okay. So this number here, we know is negative. So that's the integral. We know it's negative. If you want, you can do with a calculator and you will see that the value is negative. So the area, please remember, must be positive. So the area is going to be swapping the numbers because I want a positive value. So it's going to be 12/5 root 2 minus 16 over 5. That's the area. Just be careful with negative areas. That's what they are expecting you. So I know it's a bit confusing. What do you want me to explain or do again or rewind, or what do you need me? So we have the problem with these root functions is that when you integrate them, okay, you add 1 to the exponent, it's okay, you divide by the new exponent, and then you have this expression once we have simplified a tiny bit the coefficients. The minute you have to give your answer this way, things become a bit more complicated. So when I substitute the 4, I have 4 to the power of 5 halves, to the 3 halves, to the 1 half, and so on. When I substitute the 2, I have all of these. When I do 4 to the power of something half, that half is doing the square root, so it becomes 2. And then it's 2 to the power of 5, 2 to the power of 3, 2 to the power of 1, which is easy. But here, square root of 2 is not the whole number, so I will have to leave square root of 2. Yeah. So 2 to the power of 5 halves is square root of 2 to the power of 5. I can get 2 of those. Yeah. So is 2 to the power of 2 and then root 2. And this one, for the same reason, I can get one out, 1 in. And this one is root 2. So it requires a lot of working out that you need to be very confident working with charts, because it's something the calculator is not going to do for you. Yeah. Is the question clear? And have you noticed that I just multiply by -1 everything to swap signs, because I know this number is negative, even if it doesn't look like, because you're not very sure maybe what the number is. We know the integral is going to be negative because it's below the x-axis. So we have to swap the numbers to give the answer positive. Yeah. And they asked me to write in this particular way. Is it clear? Yes. Yes. Okay, Priyanka. Yes. No questions? Okay. Then let's do another one. This one. I think this one is slightly easier. So you have to show that this integral can be written this way. So now we have a constant in one of our limits. So what we are going to do is to integrate as normal. Then we are going to substitute the value and the constant, and then we are just leaving it in terms of the constant. Yeah. So please do it. Remember, we are going to rewrite this with the root x in the numerator and to the power of a half. So it will be to the power of -1/2. Yeah. So before integrating, we are going to write this as 6 minus 12, and the x goes up and this way. because that's what we know how to integrate. Yeah. So please integrate, and then we are going to substitute. So I'm going to have 6x and then minus 12 x to the power of 1 more. So minus a half plus 1 is positive a half. And then I divide by a half, which means the 1 can go down and the 2 up. So I'm going to write here the 2. Yeah. And then between 1 and a. I substitute the a. And I substitute the 1. Minus minus 18 becomes positive 18. Yeah. You see what I've done, no? So I rewrite this expression with the x in the numerator, so I know how to integrate it. Then in this one is 6x, and this one increased by 1, so it becomes a half, positive a half, divided by a half. So the 1, I wrote the 1 here, but the 2 up. I wrote 24 instead of 2 times 12, and then when I substitute the a, I have 6a minus 24, a to the power of a half, which is root a, and then minus, and substitute the 1. Yeah? And that's what we needed to find in the first part. Then this curve, so the one that we just integrate, and the line x equals 1, so this one here, this is not the x-axis, is the x equals 1, as shown in the diagram below. Shaded region R1 is bounded by the curve, the line x equals 1, and the x-axis. And the shaded region 2 is bounded by the curve, the line x equals a, and the y x-axis. Yeah, so the drawing is quite clear, the sketch. Is given that the areas R1 and R2 are equal. Find the value of a. There is more than one way of doing this question. One is very straightforward. Very straightforward. If you realize of that thing that happens, you will get the question done in 1 minute. What would be your first reaction to do the question without thinking too much? What would you do? You probably would find this point, yeah, which is the intersection of this graph with the x-axis, which is not difficult, yeah? We can find this point. Then you can integrate between 1 and this one, find the area, and then you integrate between this one and this one, find the area in terms of a, make them equal to each other, and from there you can easily find a, because it's going to be a linear equation. Yeah, that would be probably what most of us could do without thinking too much. But they have asked us to find the integral between 1 and a. So between 1 and a, not between 1 and this point or this point and a. And that's probably for a reason. So what can I do with this integral that I just found? Look and tell me, any thoughts? What can I do with that integral? If this area and this area are equal to each other, what is going to be that integral? Zoe, tell me.
It equals to 0.
Yes, exactly. So if this area is equal to this one, that means that one is positive, one is negative. When I add them, it's going to be 0. So this is going to be 0. And that's the fastest way to find a, because then I don't have to find this point. I don't have to integrate this. I don't have to integrate this, make it equal to each other. Yeah. So exactly, I'm going to make this equal to each other 0, because the area is going to be 0. Yeah. So 6a plus minus 24 root a plus 18 equal to 0. And that's something that maybe we don't realize. Yeah. So always look at the previous part of the question just in case it helps you. What type of equation is this one? Priyanka.
A hidden quadratic.
A hidden quadratic. So I have something and the same something squared. Yeah. So you can change variables if you want. You can write that root a is x, and then you are going to solve 6x squared minus 24x plus 18. Or if you don't want to change variable and carry on with the root a, it's completely fine. Yeah. So let's going to factorize this one. I could do, it's really up to you how you solve these quadratics. So you can factorize, it will take a while to think, or you can just use the formula straight away. Sometimes the formula is faster. What I would do is solve it with a calculator to give me an idea of what I get. Yeah. So if you solve it with a calculator, obviously you're not going to write the answers because then you wouldn't get the marks. But we get 3 and 1. 3 and 1. Have I done it correctly? 3 and 1. Sorry, I can simplify. It's even easier. I can simplify divided by 6. So I get x squared minus 4x plus 3 equal to 0. And now it's super easy to factorize. 3 and 1. Do you see why it's a good idea to check the calculator? Because sometimes it gives you the answers and then you go backwards a bit. So we have x equals 1 and x equals 3, but x was root a, remember? We change it just because it's easier to work with x and x squared than with a and root a. So if root a is 1, that means that a can be 1, and if root a is 3, that means that a is 3, yeah? Do we have any restriction for a? Find the value of a. Yes, so we have that a is 1 or that a is 3. No, 3, no, 9, no? No, 3. 3, no, I say 9 and I wrote 3, no? 9. I'm just doing the square of both sides. A cannot be 1 because 1 is here. So we will be doing the whole thing between 1 and 1. So a must be the other value. That's why if this say find the possible values of a, okay, we have 2, we answer both. But when it say find the value of a, that means that you have 1 and there is a way to choosing 1. Yeah. So sometimes it's because they say a is positive or is greater than something, and then it will help you to choose. In this case, a is going to be 9 because it cannot be 1. Yeah, if not, we will be integrating between 1 and 1. Yeah. Is it clear, the question? So you saw how we are playing with positive area and negative area, and it helped us with the question, and we did it much faster. Yeah. Okay, I think I have one more, which is this one. So we have figure 2 shows a sketch of part of the curve C with this equation. So we have a quadratic. A quadratic? No, it's not a quadratic because I have x squared and root x, so it's slightly different. Is this one here? And the point P lies on C and has coordinate x4. So we know this is 4 something. The line L is tangent to C at P. And we have to show that L has that equation. So quite similar to the one that we did before, we need to find the tangent at that point. So like we did before, we are going to differentiate the function. We are going to substitute the x by 4, and we are going to find the gradient. And with the gradient and the point, we have the line. Yep. So let's differentiate the function. I have 1/3 x squared minus 2 root x plus 3. Yeah, so I'm going to differentiate the function to find the gradient. We have 2/3. Be careful when we change between differentiation and integration. It's quite common to get mixed up with the exponent. So sometimes we add them instead of subtracting. So instead of going up, go down. So be careful of what you're doing. Yeah. So this one is the first one, then minus, and remember I have x to the power of a half. Yeah. So the half goes to the front, and I have 2 times a half x, and this down by 1, and then no, plus nothing else. Yeah. So I have 2/3 x and minus x to the power of minus a half. When x is 4, I'm going to find the gradient. So the gradient is going to be 2/3 times 4 minus x to the power of minus a half is like having 1 over x to the power of a half. Yeah, so root 4. So I can do this with a calculator. I don't think it's going to help much. That's a horrendous gradient, no? Did you get that gradient? Yeah, no? That's the gradient. No, the gradient is 13 over 6. So I'm doing, no, root 2, I'm silly. Root 4 is, so this is 1/2, yeah? 13/6, no? 13/6, that's the gradient. So we can use the same that we did before. With the point, we have the x coordinate. So the x coordinate was 4, but we need the y. So we have the x coordinate and we need the y. How are we going to find the y? We have the equation of the line. Yeah, and the point is in the line. So we are going to substitute the x by 4 and see what we get for y. Yeah. So here, when x is 4, the y is going to be 1/3 times 4 squared minus 2 root 4 plus 3. Yeah. And this is 13/3, no? 13/3. So this is the y of point P. Yeah. And now if I go back to my line, I have y minus, we say 13/3, no? 13/3 is going to be the gradient, 13/6, x minus the x of the point. And this is the equation of the line. We just need to make it looking like this one here. Yeah, so we want all the terms simplify in one side. So we have, we can expand the brackets first. So minus 13/3 is 13/6 of x minus 26/3. Yeah, 26/3. I can cancel that. So I have y. Do we have the y first? No, we have the x first. So 13/6 of x minus y. And then I have, if I am on the right side, I have 13/3. So minus 13/3 equal to 0. And I am going to multiply everything by 6. So I have 13x minus 6y minus 26 equal to 0. And hopefully that's what we have to find. Minus 6y minus 1. Yep. So we have done the same that we did in the other question. Just this question is a bit worse because of the fractions. Yeah, but we are doing the same. We have used this in this point and with the gradient that we found. Yeah, so this was the gradient and this is the point. So this is the equation that we are looking for. Done. Yes, for everyone? Yeah. Then once we have found the line, they say the region R shown shaded is bounded by the y-axis, the curve, the line, and the x-axis. Find the exact area of R. What am I to do? I'm sure you can see it now. Mainly when you draw the little dots. What can I do? Faria, what would you think? What do you think you can do to find that area? What are you going to integrate? What are you going to subtract? Or what are you going to do? Faria, integrate. You don't have the microphone, do you? I'm going to integrate. So if I integrate from here to here, I'm going to find this area. And what I'm going to do after? Subtract the triangle. That's it. Perfect. We are going to subtract this triangle here. So let's go into integrate between 0 and 4. Yeah. We integrate the function between 0 and 4. So the big area is between 0 and 4, and the function was 1/3 x squared, 1/3 x squared minus 2 root x. I'm going to write x to the power of a half, and my plus 3. Plus 3. Be careful because first we differentiate the function and now we integrate it. Yeah, don't make the mistakes. So is x to the power of 3 divided by 3. I'm going to multiply already for the 3, so I have 9. Then minus 2 to the power of 1 more is 3/2. So minus 4x 3/2 3. I'm just simplifying the coefficients. Plus 3x. And this is between 0 and 4. So when I substitute the 4, I have 4 cubed 9 minus 4 times 4 3/2 3 plus 3 times 4 and then minus 0. It's worth it to write the minus 0, yeah? So they see that you know and you just haven't forgotten. I get 76/9. Yeah, just being careful. 76/9. That's the area, the pink area that I draw here. So all the area under the graph. The area of the triangle, we know the height is 13/3. We need this length. We have this point. So what we need to find is this coordinate here. Yeah. So where the line cuts the x-axis. So in our line, we are going to make the y equal to 0. If we make the y equal to 0, we have 13x minus 26 equals 0, which means x is 2. So this point is 2. So our triangle has length 2, base 2, and height 13/3. Yeah, can you all see the size of the triangle? So the area of the triangle is going to be 13/3 times 2. We say divide by 2. Yeah, all divide by 2, which is 13/3. Yeah. So the area that we need is going to be the whole pink area, the 76/9 minus the area of the triangle, which is 37/9. No? Did you get that value? Yes? Okay, perfect. With these questions, sometimes I get the wrong number and I start to see strange faces and I think, no. Okay, so this is it. This is the type of questions that you can find. When you do integration in GR13, you're going to have lots of functions to integrate, and the difficult part is to integrate the functions. If you have areas with integrations, most of the time are going to be just polynomials. So are going to be functions like this one. Sometimes you could have an exponential, sometimes you can find another function, but you will work in the same way. You are going to work integrating some parts and usually subtracting from a triangle or from a rectangle or adding, but the idea is the same. And I think it always helps you if you think, what area I'm getting if I integrate this function, and just think that it's always the area under. And the other thing that you have to remember is that when the graph is under the x-axis, your integral is going to be negative, but your area must be positive always. Yeah, so be careful, because if you have a change of sign, and you calculate the area integral from the beginning to the end, you're going to have a value smaller than it should be. Yeah, so you have to split it in bits, like we did in the first question. Yeah. Do you have any question? No? Okay, then I will see some of you at 3:30 and everyone else next week. Yeah, the same time. Okay, bye-bye. Enjoy the rest of the afternoon or evening.
Thank you.
Bye. Bye.
Thank you.